Good morning to all. In the last class I taught you about the centrifugal test, right? In this class I am going to teach you about the one of the most important topic. Also, it's a new unit, that is gearbox, right? What's the gearbox? It's a combination of a number of gears to transmit the power from driver to driven, right? Driver to driven shaft, right? That we need to design. Based on the requirement, based on the required power transmission range. Right? For that we need to design a gearbox. Right? In this class I am going to teach you about the design of gearbox. How to design a gearbox. Right? For that we need to select the spindle speed. First. For selecting the spindle speed, we have different step ratio conditions. We need to find the step ratio. From the relation n max by n minimum equal to n minus 1. Right? From this we need to find the step ratio. Right? Step ratio how we can find? With the help of the basic series. In the problems they will mention the basic series R5, R10, R20, R40, R80. Based on that we need to select the step ratio. Right? With the help of that we can find the values. In the second step that is the structural formula. This structural formula we can find based on the spindle speed, number of speeds. In the automotive vehicle have 5 speed or 6 speed or 8 speed or 9 speed or 12 speed and 14 or 15 or 16 or 18 speeds. Number of speeds we need. How many number of speed we need for that particular machine or particular vehicle. Based on that we need to design a structural formula. We need to make a structural formula. Suppose I am going to consider to design a vehicle with 6 number of speeds. 6 speed gearbox. 6 speed gearbox means we can select from this any one of the structural formula and design a gearbox. Suppose I am going to design a 8 speed gearbox means we can select any one of the structural formula and design a gearbox. Right? Like that we can design, we need to design the 9 speed gearbox means we need to use this structural formula to design a gearbox. Suppose we need to design a 12 speed gearbox means we need to select any one of the structural formula and form a gearbox. Right? Suppose we need to design a 14 speed gearbox means we can select any one of the structural formula and make the gearbox. Like that only we are designing a number of speed from the structural formula. Select the suitable structural formula and form a ray diagram for that. Right? Suppose it is 6 speed gearbox. I am going to design a 6 speed gearbox means for that how can I draw a ray diagram? In the first shaft have the 3 speeds. In the second shaft have the 3 speeds. Like that. Number of shaft is available. Right? Number of shaft we have. Based on that we need to arrange these speed alignments. Right? This ray diagram is the graphical representation. The ray diagram is the graphical representation of the drive arrangement in the general form. That means we can arrange the graphical representation in the drive arrangements. That means how much amount of speed variation, n max and n minimum. Suppose minimum speed is the 600 rpm means that's the maximum speed. Based on that we need to draw a graph graphical representation. The graphical representation is the ray diagram, right? From this we can find the transmission ratio. From that we can find the transmission ratio and the stable operation speed ratio, right? If the transmission ratio should be 1/4 to 2. That limit is only the 1/4 to 2, right? Y means the minimum value. The minimum value will be n minimum by n input, right? The minimum value, the minimum transmission ratio is the 1/4 and maximum transmission ratio, that is n max by n input is equal to 2. That is the limit. That is the limit, right? Then for stable operation, we need to set the speed ratio. We need to find the speed ratio at any stage. At any stage, it should be n max by n minimum ratio will be 8. At any stage, right? For stable operation, right? It should not greater. It should not greater than 8. Okay, right? That is the main important thing. Suppose it will be greater than 8 means it is not a stable condition. It is not a stable condition, right? Then this is the fourth step. This is the kinematic layout. Kinematic layout is the physical arrangement of the gears in the gearbox. How we are arranged the gears in the gearbox. In the first gear, in the driver gear, how it is engaged with the driven, right? And how it will be transmit the speed, how it will transmit the power, right? That is the main thing. It shows the physical arrangement of the gears in the gearbox. Number of shaft is available, number of gears is available, and how it will be engaged. That is all available in the kinematic layout, right? That we can find with the formula n equal to P1 of x1 into P2 of x2, right? That is the formula for finding the kinematic arrangement, right? Last step, that is the calculation of number of teeth. Number of teeth is available in the each and every gears. Each and every gears we need to find, right? Then we can find with the help of the suitable conditions. Here we are using the first pair. For first pair, for driver, the Z minimum is equal to model will be 17 and assembly Z is equal to 20 for driver, right? These are the basic procedures. Based on the problem, small variations will be there, right? There will be a small modification will be there. Otherwise, the procedure is common, right? This is a major and most important procedure for designing a gearbox, right? In the next class, I will teach you about one of the most important problem in the gearbox designing, right? Thank you.